Yes, class. Now, see, we had started with refraction. We had completed apparent depth. And two things we were discussing after laws of refraction. Laws of refraction also we had covered. So we did when the ray of light will bend towards the normal and when the ray of light will bend away from the normal. So if the ray of light travels from rarer to denser medium, it bends towards the normal, and whenever it is from denser to rarer, it will bend towards the normal. This is what we had discussed. We discussed Snell's law as well. Snell's law questions also we did. Now see, before we start with total internal reflection, one topic is there. Two topics are actually there. Refraction through compound plate. Now see, try to understand this step by step, because whatever you've studied for simple basic refraction, this will be just repeated. So who all have joined? Emin, Priyadarshini, Reem, Sahal, Sara, Vakia. Now see, refraction through compound plate means if multiple media are present. One is your air. Now within this air, a plate has been added which can have more than one refractive index. It means it has 2 to 3 medium in between. Fine, 4 to 5 media in between, any. For example, I have taken 2 over here. So let's say N1 is the refractive index of air outwards. N2 is the refractive index of this yellow part. And N3 is the refractive index of this orange part. Now see, incident ray, a ray of light is incident at this point. So what is happening right now? In air, you have a plate kept in between, and ray of light is incident on this plane. So angle of incidence, we discussed it. It's the angle that is formed between the incident ray and normal. So angle of incidence is formed at this point A. Now what will happen? This is N1, N2, different media there. Speed will change, velocity will change. So as a result, refraction of light ray will occur. This incident ray was to cover a straight path. But now what is happening? This ray of light has bent. Let's say this is R1, first angle of refraction. Now what will happen? Once this ray of light will cross at this point or will reach at this point B, this is now acting as an incident ray for this point B. This part is over. At A point, this was angle of incidence, this is angle of refraction R1, this is over. Now coming to point B, what happened to the refracted ray that was passing through point A? This is now the incident ray for this new point, that is B point. So at point A, it got refracted and now it is incident at this B point. I'll show you this first. Now see, look here. This was incident here. It got refracted here. Now this refracted ray, now this is what is happening to this refracted. This is acting as an incident ray now for this point. And what about the angle of incidence? See, this ray and this ray both are parallel to each other. If this is R1, then according to alternate angles, this will also be R1. Agreed? This is R1, this will also be R1. But R1 is not actually angle of refraction right now for this point B. This is angle of incidence for this point B. Are you understanding this difference? Right? R1 is the angle of incidence because this is the normal. Now what will happen? It will again, since another medium is there, this is a different medium. So again, refraction will occur because we have studied refraction occurs whenever there is change in the speed of light. So here again, refraction will occur, same story. This will become, let's say, some different R2. And this, again, this refracted ray for this point C, it will become the incident ray now. And similarly, you will have this angle, same as that angle because of alternate angle. And finally, the ray will again refract. So here, refraction is occurring at 3 points. This is point A, this is point B, and this is point C. The final ray that emerged out of this compound plate, this complete compound plate, whatever ray emerged, we called it as emergent ray. Fine, we are calling it as what? Emergent ray. Now, angle of emergence is basically angle that the refracted ray is forming with the normal. So even if you use the term emergent ray or the final refracted ray, both are same. Emergent ray means refracted ray only. an angle of refraction. This was angle of refraction. So this is again angle of refraction only. We are just using the term angle of emergence. Whatever properties we have studied for angle of incidence, for angle of refraction, that will still be the same. Now see, application of Snell's law also we did it. In the last class, we had studied how to apply and perform the application of Snell's law. So see, Snell's law was what? Sine I by sine R is equal to N2 by N1. Right? This was what was Snell's law. Or one more method to write Snell's law is take the refractive index of that medium, multiply by sine of that angle. Take the refractive index of that medium, multiply by whatever is the sine of angle. So N1 into, this is N1 into, this is sine I, equal to, this is N2 into, this is sine R1. Or directly also you can write sine I by sine R1 is equal to N2 by N1. Like this also you can write. So first tell me, this A point is clear to you? Just this A point I'm asking right now. Angle of incidence, angle of refraction one, this A point. Clear to all of you? Yes or no? Okay.
Yes, ma'am.
Yes, ma'am.
Okay. So any doubts, even if you have, you can text me in between. Now coming to this point B. Now angle of incidence for this point B is what? For this point B, you have angle of incidence as R1. This R1 is acting now as the angle of incidence. So same thing, sine R1 will come now. Instead of angle of incidence I, you are having sine R1 by sine R1 by sine R2. So first you write the medium in which the ray has entered, that is N3. Then divided by the medium from which the incident ray came, or the medium of the incident ray, that is N2. Again repeating, if you want, you can write it as N2 multiplied by sine R1. See, N2 multiplied by sine R1 is equal to N3 multiplied by sine R2. Yes, it is very similar to glass slab only. It's just that instead of a single glass slab, if you have multiple glass slabs in between, so that is what is meant by compound plate. So just we'll do glass slab also right now, we'll do after this. One topic that was left. No, I was telling you two topics are left. So one is glass slab only, that we'll see. But we are taking this case so as to have an idea if more than a single plate is given. Now coming to the C point. Again, angle of incidence will become R2 and angle of refraction will be this final angle, angle of emergence. So if you put it and keep it here, so see at this point C, what will happen? Sine R2 by sine E. This will be equal to, again, now the medium in which the ray is going, in which the ray has entered. This is N1. Why N1? Because this is back to air. The light ray is coming back to the surrounding that was air. So we'll write N1 by N3. All these equations we have obtained simultaneously using Snell's law. Again telling you, if you cross multiply this, you will get N3 into sine R2, N3 into sine R2 is equal to N1 into sine E, N1 into sine E. If you are not able to recall or you're not able to remember which ray of light will, whose refractive index will come first, so remember by this only. The refractive index of that material multiplied by sine of that angle is equal to refractive index of the next material multiplied by sine of that angle, like this. Now, finally, what we have to do, see, if we have all these three equations, now let's divide all these three equations. So sine I by sine R you have. This is sine I by sine R1 into you have sine R1 by sine R2 into here you have sine R2 by sine emergent, angle of emergence. First one was N2 by N1, right? Second one is N3 by N2. Last one is N1 by N3. I have just multiplied all of these, all these three equations. See, sine R1 gets cancelled. Sine R2 gets cancelled over here, right? N2 gets cancelled. N3 gets cancelled. N1 gets cancelled. So what do we have? We have sine I by sine E as 1. It means sine I is equal to sine E. Angle of incidence is equal to angle of emergence. This shows what? And yes, class, how the question will come from this? You can get a question. Show that the incident ray and the emergent ray both are parallel. So you'll have to show all these steps. Why? See, class, if you extend this, no, this will be exactly parallel to this emergent ray. Why? Because this angle and this angle is equal. So if these two angles are equal and you draw it here, so it will appear that this is acting as a transverse in between, and that is parallel. So incident ray and emergent ray both are parallel to each other, exactly parallel to each other. And this angle of incidence will be equal to this angle of emergence. So in your theoretical questions also, if small marker questions are asked, there also you can be asked relation between angle of incidence and angle of emergence, and simply show refraction through compound plate can be asked. From this theory part only is asked. You don't have numericals from compound plate usually. You have numericals from lateral displacement that we'll do after it. First note it down. Then we'll do one more topic before starting with TIR. Okay, I think most of you have completed this. Now next topic. Yes, I was saying lateral displacement that we have to do. Displacement, lateral shift in glass slab. Now see, glass slab, we are just having a single plate. We are not having right now two different plates the way were having in case of compound plate. So compound plate was made up of two material. Both the refractive indices were there. N2 was for the yellow material, and for the orange we had it as N3, and the rest of the surrounding was air N1. Now, same thing is happening, single plate I'm taking. So if I'm taking a single plate, it means refraction will occur at the both edges of the plate only. Once the ray is entering, at that point refraction will occur, and when the ray is leaving, at that point of time, refraction will occur. Now we have to find out if the incident ray travels its own path. Let's say refraction didn't occur. Somehow, let's say refraction didn't occur. So if refraction does not occur, this incident ray of light will keep on moving in the straight path itself, fine, as it is. If this is moving in the straight path and this is emergent ray, what did we conclude in the above derivation that we did? We just concluded this fact that incident ray and emergent ray are parallel. Both the rays are parallel to each other. This was what we had concluded. So what is this gap that we are obtaining? There's a gap, no, that is placed since they are parallel, they are not overlapping with each other, they are not intersecting at a point. So there's a maintained perpendicular gap between them. That perpendicular gap which is there between the emergent ray and incident ray, and that too incident ray's original path, that is known as lateral shift. Lateral shift, you can say lateral displacement also, you can say. The definition is also here. It is the perpendicular distance between incident and the emergent ray. Now there's a formula for this, for which we'll calculate it. So I'll just drop a perpendicular here, that is BN. So this forms a triangle ANB. Now firstly look at this triangle. This is angle of incidence I. Can anyone tell me what is this complete angle there? If this is angle of incidence, what is this angle? Look in the figure. Yes, Priya. Right. Priyadarshini, correct. This will also be angle of incidence. No reason. Vertically opposite angles. These are vertically opposite angles. This is the angle of incidence I. So this will also be I. From here, R has been taken out. R has been subtracted. So what will be left over here? This angle. This will be I minus R only. This complete was I. From here, R has been taken. So the leftover will be I minus R. Let's say total was 30 degree. 15 degree I have taken. So 15 degrees will be left. This part is clear why this angle is I minus R. Now we are focusing on this I minus R. Wherever you're not able to understand, stop me. This goes for you as well. Sarah, if you wherever you're not able to understand, just stop me, because some of the topics you have not done since this is the middle of the lesson. So let me know any part that you want me to repeat. And this goes for others as well. Now see, look at this triangle A and B, this triangle that you have. If I take sine of this angle, what is this angle? Sine I minus R. If I take sine of this angle, so sine I minus R. So this is the triangle that you have. This is the perpendicular. BN is the perpendicular. BN only is the lateral shift. No, this we are trying to find it out. So this will be BN divided by AB. Perpendicular is this. By hypotenuse is AB. Fine. And yes, one more thing. Thickness, we have assumed that the thickness of this glass slab is T. This is the thickness that we have assumed. Now see, if thickness is T, sine I minus R is equal to BN by AB, BN will be equal to, BN is only the lateral shift. So lateral shift, that is BN. This is lateral shift. This will be sine I minus R multiplied by AB. Now, can we keep our answer like this in AB? Definitely not. We have to find out what is AB. So one thing we can do, if we use this triangle, we can use this triangle as well, A and B. So in this triangle, here in this triangle A and B. So if I take cos R, this angle is R. If I take cos R, look here, A and B. This is cos theta, right? So it will be base upon hypotenuse. So base is this AM, hypotenuse is same AB. This is perpendicular MB. This is the base, this is the hypotenuse. So cos R will be AM divided by AB. Can anyone tell me by looking at the figure what is AM? Can I substitute anything for AM? This AM, except for this part that this is base. Anything in by looking at the figure. Can you just notice one thing? Anyone?
L, ma'am.
Good, correct. It is thickness. Thickness, yes. So thickness is this AM. Now I have the value of AB, and this AB was only unknown. That was troubling in this. So AB will be equal to AM, that is T thickness by cos R. So I think now we have the formula of lateral shift. Shift also you can use the term displacement as well. So which is Bn, that is equal to sine I minus R. This is equal to sine I minus R. And instead of AB, I will write it as T by cos R. So this is the formula of lateral shift. All right, this formula you have to remember. Even the derivations of this are asked. Derivations of lateral displacement has been asked in your board exams and previous year questions. So do practice. The derivation is very easy. From one triangle, sine I minus R. From another triangle, cos R. Just put the value of AB into the first equation. This is just the 3-step. Since we were discussing, that's why it took time. Otherwise, this much time also will not be taken by it. Fine, so noted till here. Any doubts you have, let me know.
I'm gonna scroll up. Done, ma'am.
Done by others as well? Completed?
Yes, ma'am.
This we had covered apparent depth and real depth. So just quickly revision of what was the meaning of it. Real depth is what is the actual depth of an object whenever it is kept in any medium, any liquid, especially in liquid. Fine, let's say water. In water, if you keep a coin. So that actual depth of the container or the actual depth from the surface of water to that coin, that is known as the real depth. And apparent depth is the depth that you're able to see because of refraction. So it can be shallower, it can be greater than the actual depth. So based on this, we did the derivation and we came to the conclusion that apparent depth is real depth divided by the refractive index. And if the light rays enter from denser to rarer, real depth becomes greater than apparent depth. It means the object appears to you at a shallower distance. If it is from rarer to denser, then apparent depth becomes greater. It means actually object is at a smaller distance, but you are able to see it beneath. So this was what we had discussed already. Shift's formula also we did. Final formula of shift we did. That was the difference between the real depth and apparent depth. So this much we had completed. Now starting from total internal reflection. This is also one of the very important topics. From your refraction, most of the topics that have appeared and have repeated, one of it is total internal reflection. Lens maker formula is one, total internal reflection is other. Lens maker formula, I think we didn't do it right now. When we do spherically refracting surfaces, that's the end portion of refraction. But total internal reflection is one of the very major topics. Now see what is meant by total internal reflection. C class. Rarer medium is there, denser medium is there, their interface that has been that is separating both of it that I have displayed. Now see what will happen. Now what will happen? Let's say ray of light is incident from the denser medium. The ray of light is incident in the denser medium. So this will be like this. Let's say this is incident on the denser medium. So what happens if the ray of light is from denser to the rarer medium? Will the refracted ray bend towards the normal or away from the normal? This is the normal. Normal has been drawn. Will it be towards the normal or away from the normal? Yes, class, we even discussed it today. Check into your notes, you must have written it. We discussed the same thing today. Before starting with it, this part, class, this part. If your ray of light is from rarer to denser, it means rarer medium towards the denser medium. Then the ray of light bends towards the normal. If your ray is from denser to rarer, then it bends away from normal. So remember this because this condition is necessary. Now what will happen? This will bend a little away from the normal. So this is angle of incidence. This is angle of refraction. Normal simple refraction occurred. Nothing new in here. Now see. I am increasing the angle of incidence. Let's say the inclination I am increasing. This was the normal. And this angle of incidence I am increasing. So this will also increase simultaneously. Angle of incidence I have increased. So in response to this, angle of refraction will also increase. Now see what will happen. Same till now, this is the basic refraction. Let's say I have increased it a little bit more. This is the normal, and I have increased it a bit more. Now what I'm observing, where will this refracted ray go? Where it will go? So what has been observed is that this refracted ray what has been observed is that this refracted ray, this simply grazes it like this. It means now, where will this refracted ray bend? Where will it go? So as we increase this angle becomes 90 degree, which is angle of refraction, and this is angle of incidence. Fine. Again, let's say angle of incidence has been exceeded. This is some angle of incidence. Now where the refracted ray will go? Where will it increase itself? Till now, it grazed over the surface. It kept on increasing itself. Now where will it go? So see, now it will move here within this medium because there is no space left for this to move. This was angle of refraction and this was the refracted ray that was grazing on the surface. If the refracted ray that was grazing on the surface, now the angle of incidence is increased again. So if angle of incidence is increased, it means this refraction will occur within the same medium. Now, can you look at this? Is this refraction or reflection? This is angle of incidence. This is angle of refraction. This is not refraction. This is reflection, simply reflection, right? Yes, Wafi, agreed?
Yes, ma'am.
So this is your angle of incidence. This is your angle of refraction. Now see class. This phenomena, that is bending of light or the reflection that is occurring within the same medium, that is known as total internal reflection. And now see this angle for which the angle of refraction suddenly reached this 90 degree. This angle of incidence is known as critical angle. This has a special name which is known as critical angle. So exactly at critical angle, your angle of refraction becomes 90 degree. Before that, that was normal angle of incidence for which you were having different values of angle of refraction and the phenomena of refraction was keep on going. Now what is happening? Exactly at such a particular angle where suddenly your angle of refraction becomes zero. Because you all know, as the angle of refraction will become zero, what will happen? It will graze over the surface because 90 degree will be formed like this. So this angle is known as critical angle. Now see one thing class. When till this step in this third figure, this was first, this was second, this was third, this is fourth. In fourth, did we keep the angle same? Did we keep the angle exactly same? No. What we were continuously doing? We were increasing the angle of incidence. So I was increasing the angle of incidence from 1. You can even look in the figure. 1 is having a narrower angle of incidence. Fourth is having a greater angle of incidence. So what is happening? We are exceeding the angle. So exactly at fourth figure, your angle exceeds critical angle. The angle of incidence is greater than critical angle. Then only this refracted ray could come into the surface within the same surface and get totally internally reflected. Now, two conditions which you have to remember at any cost for total internal reflection to occur. First, very condition that prime condition is that your incident ray didn't go from the rarer to denser medium this time. Look at it. I have clearly shown that this is the denser medium, which is now going into the rarer medium. Let's say this is air, this is some glass, any medium that is. So for total internal reflection to occur, your incident ray should move from denser to rarer medium. Firstly, this point. Secondly, for total internal reflection to occur, your angle of incidence should be greater than this critical angle. If it is not greater than critical angle, if it is equal to critical angle, then angle of refraction will be 90 degree and refraction will occur. This is also refraction only. If it is less than critical angle, then simple refraction will occur with angle of refraction less than 90 degrees. Right. So for total internal reflection to occur, your incident ray should move from denser to rarer medium. Your angle of incidence should be greater than critical angle. And what is critical angle? Critical angle is the angle of incidence for which angle of refraction is 90 degrees. Also, one more point class that you should keep in your mind that total internal reflection is occurring within the denser surface only. It is not occurring, nothing is happening in the rarer surface now. Because your incident ray will always be in the densest surface for in total internal reflection to occur. So if it is in the denser surface, then your reflection will also occur in the denser surface. Then again, laws of reflection and everything all lie in the same plane, that will be obeyed. This is what is meant by total internal reflection. So I'll read out the definitions that have been written. So the phenomena in which a ray of light traveling at an angle of incidence greater than critical angle, this is one most very important condition for TIR, because this can be asked to you separately. That's why I'm emphasizing on it. Otherwise, you could leave it or you could escape it from your notice. You have to keep it into your mind because in your exams, TIR, as I've told you, total internal reflection is a very important topic. Difficult questions come from TIR throughout this ray optics. No, if you notice the types of questions that have occurred, though TIR has nothing significant formula or not a very big definition, but if you will notice from TIR, the questions that have come, because it is a combination of refraction and reflection, tough questions come, not just for a class board, from your entrances perspective also. In your entrances also tough questions come. And in your board examinations also, you have good standard questions from TIR. And rest of the topics, if I'll tell you, this is I think the most difficult topic of the entire lesson, ray optics. Even optical instruments questions are direct. Prism questions are direct. Apparent depth questions are direct. Mirror formula, lens formula, these will be used by you. These are somewhat direct questions. I was telling you already that ray optics, please revise it simultaneously after the classes only. And before the next class occurs, try to keep all the previous topics revised, because ray optics is one of the difficult topics of the second. And this is the only topic that is difficult, the only lesson that is difficult. The rest of the chapters that are present, wave optics, semiconductors, your modern physics, these will be covered easily. So pay attention to ray optics, and from ray optics, pay attention to total internal reflection. One thing is that your numericals will be standardized. Tough numericals can come from total internal reflection. Your direct theory can be asked from it. Applications of total internal reflection is there. That I'll discuss with you. That is there. Simple definition of TIR along with its condition can also be asked, where you have to show this page, whatever page I have written, right? So pay attention to TIR. So you can be asked conditions. So one is phenomena in which ray of light traveling at an angle of incidence greater than critical angle from denser to rarer medium. Because if this is not the case, and if this is not the case, TIR won't occur. So this is known as, and yes, so phenomena in which ray of light traveling at an angle of incidence greater than critical angle from denser to rarer medium is totally reflected back into the denser medium is called total internal reflection. And what about this critical angle that was present? So angle of incidence in the denser medium, for which angle of refraction in the rarer medium is 90 degree. This is known as critical angle of the denser medium and is denoted by small I with the subscript C. This is also sometimes denoted by capital C. Capital C can also be written like C is 42 degrees. Like this example, it can also be written. So if even in some books or anywhere you find it as capital C, do not get confused. That is a critical angle. Now for critical angle, for total internal reflection, you don't have any as such specific formula for it, because that is reflection. You already know what is reflection. You have studied reflection, then only know you are arising at it. But for critical angle, we can do one thing. We can draw out, let's say, this refraction, this is N, and this is air. So let's apply Snell's law over here. If you apply Snell's law, what will you obtain? Refractive index is 1 for air. So 1 into sine R. This is sine R is equal to N into sine IC. This is how we take, how we apply Snell's law. And yes, class, wherever still you're having difficulties in application of Snell's law, please stop me there. Because application of Snell's law, as I've told you already, that Snell's law direct questions will not come. Direct questions are very simple that you will manage, but application of Snell's law is throughout till the end. Last topic that we'll do will be prism, and then that also we'll be having Snell's laws application. So this is N into sine IC. So 1 into this is sine 90 degree is equal to N into sine IC. So from here, a very straightforward formula of critical angle we obtain. That is sine IC is equal to 1 by N. This is only Snell's law. No new formula has been done. This is just written separately, so that we can at least have an idea of how to apply Snell's law. And if separately questions are asked from your critical angle, then also you are able to handle it. You should be able to handle all the questions of it. Note it down. Any difficulties, any queries you have, let me know. Theory part, make it clear. Any doubts you have from theory part, make your theory also stronger for this part. I am personally insisting you to revise total internal reflection and practice all the numericals. Even in your NCRT, good numericals are given in text question as well as in your back exercises. So have a good practice of total internal reflection. Just one more thing, class. This was an example that I taken. No, that air. It can happen that this is some other medium. So instead of writing this as air, you can write it as NR also. Air, this was just an example. NR and ND, make it NR and ND. Then only you'll be able to remember that this can have some value. This can not necessarily be one all the time. It can be the refractive index of the rarer medium, and this is refractive index of denser medium. So 1 by NDR. It means NDR is what? This is ND by NR. One more thing, class. For glass and water, please try to remember the refractive indices for glass and water. Refractive index of air, not water, glass and air, these three materials. Because it can happen that in your exam questions will be directly given on it and refractive index is not. So for air it is 1 discussed, glass it is 1.5 and water it is 1.3. 1.33, but 1.3 will be sufficient. So for glass 1.5, for water 1.3, for air 1. These three can be omitted in the question in your exam paper. Because chances are there, like this is a question from your past question only, and just glass and air was given. So critical angle for glass air. So refractive index of glass is what? Refractive index of glass. This is 1.5. Refractive index of water is 1. So not water, air. Air. So see, NDR means here it will be NGR. Denser is glass and rarer is air. So NGR means NG by NR. That is 1.5 by 1. And you know sine IC is 1 by NDR. So sine IC will become 1 by 1.5. So critical angle will become sine inverse by 1 by 1.5. Fine, note down this numerical. Then we'll do some good numericals from this. 2 numericals at least we should do. Okay, class, the question is given at this surface. No, this is simple glass slab is there, and it's an important question. It's a question from a previous year, so pay attention to this and mark this question and the next question that we'll do as important only. See, incident angle of incidence is 70 degrees, that is given to you. Fine, let's say this point, let's mark this point, this as M, and this point, let's say this is N. Let's say this point is P. Now, since here the when the normal is dropped, this angle is 90 degrees. So can you name what is the side what is this angle then? If here 90 degrees formed, then what is this angle? Yes, class. Which angle is this? Here, once refraction is occurring, angle of refraction is 90 degrees. 90 minus R, that is fine. See, that is critical angle. No, this is critical angle. Then only, no, for this particular point P, you are getting the angle of refraction as 90 degrees. Do you understand this? 90 minus R, that is right. That we'll use in our numerical. That we'll use here for the finding of this answer. Now, the question is to find out this angle of incidence with this much of data that is provided to you. So firstly, for this, let's name this. This is A, this is B, this is C, this is some D point random. Now see, for this vertical face BC at this point, this is N, refractive index is N. Let's say we do not know what is the refractive index. We have to find it out because this is not given to us. So we cannot assume and keep it as N, because this is a variable that has been introduced by me. This is not a variable that is given by the question, so that I can keep it in my answer. In my final answer, N should not be there. Only the variables or any quantity that is given by the question, that can be included. So let's say for this, for the time being, for this vertical face PC, vertical face PC. If you look over here, this, and apply Snell's law over here, or simple critical angles formula, sine IC, this will be equal to 1 by N, right? Now, apply at point B. For face A, P, if you apply. So, refractive index into sine of angle, 1 into sine 70 is equal to refractive index into sine of angle, N into sine R. N into sine R. This is Snell's law applied. So sine, one more thing. Sine 70 degrees value is also given in the question. It was 0.9397. 0.9397 approximately, like this. Now let's keep it sine 70 degrees. This was given in your question, so do not worry about it. If you have such data, no, either that will be given by the question, or it will be such a value that you know the answer, like sine 70 degrees, the sine 30 degrees, and 45 degrees. So this is 0.9397 is equal to N into, this is sine IC. Sorry, sine R, not IC, sine R. So sine R will be equal to 0.9397 by N. Why are we performing so many steps? We are performing so many steps because N we cannot use. Otherwise, our critical angle is very sure. Our critical angle is very clear, 1 by N. But we cannot use 1 by N. So as to find what is this value of N, that's why we are performing so many steps. Otherwise, we could just have simply written 1 by N is sine I. Fine. So sine R I have written. Now coming to what Priyadarshini you were saying in that triangle M and P. If we talk about this triangle M and P, from here R plus this angle is 90 degrees. plus this critical angle. This will be equal to what? All the angle sum property of the triangle. This will be equal to 180 degrees. So rightly, the way you were saying, Priyadarshini, now we will have it as 90 minus R or 90 minus IC, whatever is required. So in this triangle, what was the name that I had written? MNP, no? MNP, just correct me if I'm wrong anywhere. So R plus 90 degree plus that critical angle. This will be equal to 180 degree using the angle sum property. So R plus IC will be equal to 90 degrees, right? So R will be equal to what? 90 minus IC. Remember, we had left sine R over here. Can we keep the value of R now? At least one thing we are getting in terms of the known thing. So sine R, I can write it as 90 minus IC. It can be written as 0.9397 by N. Fine. What is sine 90 minus theta? Sine 90 minus theta. Cos theta. Good. Cos theta. So if it is sine 90 minus IC, IC is your theta. Sine 90 minus IC, it means cos IC. Sine 90 minus theta, cos theta. Sine 90 minus alpha, cos alpha. Sine 90 minus phi, cos phi. So sine 90 minus IC, cos IC. Clear? Same identity. So since theta instead of theta, you have it as IC. So I can write this as cos IC 0.9397 by N. Now see class. This is cos IC. Here I have sin IC. This is one equation, let's say sin IC. This is one equation which involves cos IC. Okay? Now see, cos square IC plus sin square IC. This will be equal to what? Trigonometric identity 1. Good, Priya. This will be equal to 1. So from here you can say sin square IC will be equal to 1 minus cos square IC. Sin square IC will be equal to 1 minus. Why am I using this? Because I know sin IC value, I have it with me. So sin square IC is 1 minus under root cos square IC. So from here sin square IC can be written as 1 minus cos square IC. I can square this. This is cos IC. So if I square, this will become 9397 by N whole square. Fine, 93 minus 97 whole square. Under root also we have to take it. And yes, class, let's solve it only because otherwise this will be very lengthy. So sin IC will be 1 minus 0.9397 let's write it as 0.94 whole square by N square. Fine, 1 minus 0.94 square under root. Now keep the value of sin IC. This is 1 by N. 1 minus 0.94 square by N square. Just to obtain this equation, we had to perform such multiple steps. Why? Because now this is linear equation in one variable in which your variable is N. And once you have the value of N, sin IC is not difficult for you to find it out. Square both the terms. So this becomes 1 by N square, 1 by 0.94 square by N square. Fine. So 0.94 square by N square, the plus 1. This will be equal to 1. Taking the LCM, shifting this and taking the LCM then. So N square will be equal to 0.94 square plus 1. So 0.94 square plus 1, this will be approximately 1.88. So N square will be around 1.88. N will be under root 1.88. So now I have N. Now I think this is not difficult to solve it. Sin IC was 1 by N. Sin IC is now 1 by under root 1.88. Final answer, critical angle is sin inverse 1 by under root 1.88. So such types of questions are there in total internal reflection. Usage was nothing. Usage was very little. No, of critical angles, just basic concept. But such questions are there. That's why I'm saying have a good practice of it. Assignments also will be given. Assignment will be given. Try to practice it and send it, upload it. If you're not able to upload it on the portal, send me it on WhatsApp. All of you have my number. First, tell me, this question is clear? To all of you? Ayman, Priya, Reem, clear? Rifat? No, not at all. When you'll complete it till here, just text me done in the chat column. Then I'll stop the class. On Thursday, now we'll continue with this. One more numerical P2 and applications of PIR, we'll discuss it. So all those who will be completing the writing portion, you all can leave. Yes, you can leave. Thank you so much.
Thank you, ma'am. I love this.
Okay, Allah.